Student will go to the in Ex-11.4 fifth main, the sixth problem. We are solving problems on identities. So identities, what is the three main identities? That is sin square a plus cos square a is equal to 1, and 1 plus tan square a is equal to secant square a, and 1 plus cot square a is equal to secant square a. So using these identities, we are solving the problems, and I told you we are solving trigonometry identities. We will convert into the first step is convert into sine and cos. Now, sixth question is you have to prove that the square root of 1 plus sine a divided by 1 minus sine a is equal to secant a plus tan a. Now, if you want to get secant a plus tan, if you write in terms of sine and cos, so secant a will be 1 by cos a, and this will be sine a by cos a. So the last second step should be in this form, 1 by cos a plus sine a by cos a. So you have to make in this form. So now if you see, always previous problem we converted into the sine and cos. It is already in sine, we cannot apply any identity. So in such case, what we can do, square root is there, you have to eliminate the square root. In such case, if you remember the rationalizing factor we have done in the rationalizing factor, the previous exercise, that is, if a rationalizing factor of root 3 minus root 5 is, the rational factor of this one will be root 3 plus root 5. So we will multiply and divide by root 3 plus root 5. Same thing, we will do it. The denominator you have 1 minus sine a, so we will multiply and divide by both numerator and denominator by, we will multiply both numerator and denominator by 1 plus sine a. So multiply and divide by 1 plus sine a. So what happens if we divide and multiply? This is very important type of problem. So square root of, so it will be 1 plus sine a, okay, into 1 minus 1 plus sine a whole divided by, this is 1 minus sine a into 1 plus sine a. So we multiply and divide by 1 plus sine a. So numerator, if you see, it is 1 plus sine a into 1 plus sine a. Same terms, multiply same two terms. So we can say it is square root of 1 plus sine a whole square divided by. Now the denominator, if you see, a plus b into a minus b, a square minus b square. So this can be written as, in form of identity, 1 square minus sine square a. Identity a plus b into a minus b is equal to a square minus b square. Okay. Now we'll take root separately for numerator and denominator. Let us write. So remember what the previous second step should be: 1 by cos a plus sine a by cos a. So that you have to get. So we'll write separately for the square 1 plus sine a whole square divided by square root of 1 square minus sine square a. So now, so here we can cancel square and square root in the numerator, whole square it is, so square and square cancel. 1 plus sine a divided by, if you see in denominator, 1 square minus sine a, so 1 square is 1, so 1 minus sine square a, the identity, because from the first identity, I say that 1 minus sine square is cos square a, so square root of cos square a, because the reason you can give 1 minus sine square a is equal to cos square a. From the first identity, sine square a plus cos square a is 1. So you can take sine square a to other side, you get in terms of cos square a. So that already we have done such type of problems. Now, now we can cancel the square and square root. Cos, the single term, square and square root. So what is left out here? Numerator 1 plus sine a divided by cos a. I told you in the beginning only, you have to get the previous second step as to get this is 1 plus 1 divided by cos a plus sine a by cos a, because reciprocal of cos is secant. 1 by cos, this can be written as sine and cos. So I should 1 by cos and sine by cos plus. How to get? So if you write the denominator separately, that is 1 by cos separately for both the terms, 1 by cos A plus sin A by cos A. So 1 divided by cos A is reciprocal of secant A, and sin A by plus cos A, so divided by cos A is nothing but tan, the relation between sin, tan and cos. So tan A. So that is equal to the RHS.